Hello everyone. In this video we are going to be looking at solution to 4 questions. All of them are from the chapter areas related to circles. Quite easy, couple of them actually very interesting, 2 of them are easy questions. They appeared as part of the sample paper given by the board for the multiple choice question term 1, academic year 21-22. These questions are the 4 questions from this chapter. They appeared in both section A and section B, 1 question from section A and 3 from section B. That's what we are going to be looking at. Let's start with the first of the questions. The number of revolutions made by a circular wheel of radius 0.7 meters in rolling a distance of 176 meters is what this question is, right. So, the total distance covered by the wheel is going to be equal to the number of revolutions it made into the distance covered per revolution, right. So, if let us say it covered 4 meters in one revolution and did 100 revolutions, it will cover a distance of 400 meters. That is essentially the idea. So, what do we have as the total distance? That is equal to 176 meters. We are going to equate it to the number of revolutions into the distance covered per revolution. Distance covered per revolution, look at it, it's a circular wheel, the distance covered in one revolution, let us say this is the place where you start, the circumference of the circle is the distance covered per revolution. So, n into circumference of the circle should be equal to 176 meters, the total distance travelled. Circumference, let us call it as c, is equal to 2 pi r. Radius is known to us, let us take pi to be equal to 22 by 7. So, 2 into 22 by 7 into the radius is equal to 0.7 meters. 0.7 gets cancelled with 7 to leave us with the 10. So, the circumference of the wheel is equal to 44 divided by 10 meters. So, distance covered in one revolution is 44 by 10 meters. Total distance covered is equal to 176. So, 176 is equal to number of revolutions n into the distance covered per revolution, which is 44 by 10. So, n is equal to 176 times 10 divided by 44. 44 times 4 is 176. So, number of revolutions is equal to 40. Very straightforward, simple question. This is an interesting question. The diagram looks a little daunting, but actually it is a very simple question. In the figure given below, ABCD is a square, side of the square is equal to 14, right. So, this is given to us, done. EFGH are the midpoints of the square, right. What we need to find out is the area of the shaded portion. Let us break this into 2 parts. Let us call this the line, which is the line joining the midpoints F and H. So, we will call this as the top part and this as the bottom part. So, the shaded region, some parts of it are in the top part, top half, and the other part is in the bottom half. So, top part area is very straightforward, which is area of the semicircle, right. What we see here is a semicircle. Finding the area of the semicircle is going to be very easy. We will check out whether we actually have to find out. Area of the semicircle is area of the circle divided by 2, which is pi r square. All we need to know is the radius. If 14 is the side of the square, diameter is 14, so radius is equal to 7. So, pi into 7 square divided by 2 will give us this area. Let us see whether we will have to compute it. Let us just keep that idea in mind. Let us come to the bottom part, right. The total area is equal to the top part area plus the area of the bottom part. Bottom part, we have a rectangle. Measures of the rectangle are known to us. This is a 14, this is a 7, because the entire length is equal to 14. So, this is half of it, which is 7. Again, let us hold on. What do we have here? This angle is equal to 90 degrees. The sector that is formed is obviously a quarter of a circle, a quadrant. So, we have one such part, 2 such parts, which will have to be removed from the area of this rectangle. So, the bottom part is actually area of the rectangle HFCD, this rectangle. From that, we are removing the area of 2 quarter circles. 2 quarter circles of radius 7 is equal to 1 semicircle of radius 7. So, area of semicircle of radius which is equal to 7. Here from the area of the rectangle, the shaded region is the black one. The white regions will have to be subtracted from the area of the rectangle. Each white region, 1 is equal to quarter of a circle, 2 is another quarter of a circle. Together they form a semicircle. So, HFCD minus area of semicircle of radius 7 is what we have. So, total area is area of semicircle of radius r added to that area of the rectangle, from that subtracted area of semicircle of radius r. So, these 2 areas get cancelled. So, the area that we are looking at for the shaded region is actually the area of the rectangle HFCD. Length is equal to 14, width is equal to 7. So, 98 square units is the answer. So we needn't have, there is no necessity for us to compute the area of the semicircle at all. Not such a difficult thing, but we didn't have to find it because these two values got cancelled. What was left is basically finding out area of half the square or area of the rectangle. Again, is an interesting question, a beautiful question, this one, right? Olympic ring we are talking about. Olympic ring will have 5 circles, right? 5 congruent circles of radius 1 centimeter. We'll see the diagram in the next slide. Intersecting in such a way, the chord formed by joining the points of intersection of any 2 circles is also of length 1 centimeter. We'll see that in the next slide. Total area of the dotted region, assuming that the thickness of the rings is negligible, is what the question is. Here is the diagram that we are talking about, right? 1, 2, 3, 4, 5 Olympic ring, right? So circles intersecting. The places where these 2 circles are intersecting, you connect it. Obviously, the intersecting circles, you'll have a common chord. AB is one such common chord. The dotted region is this. This is one dotted region. So you have 1, 2, 3, 4. Each of these dotted regions is going to have the same area. So 4 times area of one dotted region is going to be the final answer that we are looking at. So if we can find out the area, this area multiplied by 4 will give us the answer. Now let's just look at these 2 rings alone, right? And then we'll see. We're just going to look at this. This is a chord we are talking about. Now this is, both of these are congruent parts, so we'll call it as 1. I'm going to shade it this way and the second one this way. So if we find out the area of 1, twice that is the area of one of these dotted regions. Let's go and find out the area of one of these alone. So let's just draw a diagram for that part alone. I'm taking this circle, we'll call it a circle 1. We're talking about a chord AB. 1/2 of the dotted region is this minor segment. O is the center of the circle. OA, OA, BC. This region that we are talking about, shaded in horizontal line, is nothing but the sector. So area of AOBC is equal to theta divided by 360 into pi r square, which is 22 by 7. Let's check out how the answer options are given. Is it in pi? It's in pi, so let's keep it as pi, right? So we'll take this 22 by 7 and replace it as a pi into r square. Radius of each circle is given to be equal to 1, so this is equal to a 1 square. So found out the area of AOBC. We need the area of the minor segment, so all we have to do is subtract the area of this triangle. OA, OB are radii which measure 1 centimeter each. They have said the chord AB also measures 1 centimeter. Therefore, the triangle that we are talking about, triangle AOB, is therefore an equilateral triangle. Area of an equilateral triangle is root 3 by 4 a square, which is root 3 by 4 1 square. Now, what is theta? If it's an equilateral triangle, all 3 angles are equal. All 3 angles are equal to 60 degrees. So this therefore will be equal to 60 divided by 360 into pi, which is equal to 1/6 of pi. So area of the sector is pi by 6. Area of the triangle is root 3 by 4 into 1 square, which is root 3 by 4. So 1/8, because 2 times this value is going to be the area of one such dotted region. 4 such dotted regions is the final area. What we have found out is half a dotted region. So 8 times this value should give us the area of all the dotted regions. So the overall area we are talking about is basically 4 times the dotted region. Each dotted region is divided into 2 parts. Each of those parts is nothing but a minor segment. The area of the minor segment is area of the sector, which is pi by 6, minus area of the equilateral triangle, which is root 3 by 4. So the answer is equal to 8 times pi by 6 minus root 3 by 4. Let's just check out whether the answer option is given in the same way, right? 8 times pi by 6 minus root 3 by 4 is the answer. Choice D is the correct answer to the question, right? Again, it's a very easy question. The circumference of a circle is 100 centimeters. Okay, so 2 pi r or pi d, d being the diameter, is equal to 100 centimeters. Side of a square inscribed in the circle, what is the side of that square, right? This is how the diagram looks. This is the circle we are talking about. If a circle circumscribes a square, or a square is inscribed in the circle, the diagonal of the square will be equal to the diameter of the circle. Diameter of circle is equal to diagonal of square. We know the circumference is equal to 100. So, pi times the diameter, which is d, is equal to 100. So, d is equal to 100 divided by pi. Diagonal is equal to, d is the diagonal, d is the diameter. This will be equal to root 2 times the side a. So, a is equal to 100 by root 2 pi. Check out how the answers are given. Do we see 100 by root 2 pi? No. So, we will rewrite it a little bit. 100 by root 2 pi. We will write the 100 as a 50 into 2. 50 into root 2 into root 2 divided by root 2 pi is what we have. Root 2 gets cancelled with root 2. So, final answer is 50 root 2 divided by pi, which matches the answer that we have here. 50 root 2 by pi centimeters. Choice C is the correct answer to the question. So, key idea in this question is, if a square is inscribed in a circle, the diameter of the circle is equal to the diagonal of the square. Before you leave, I want you to do two things. One, sign up at online.maxtute.com to get started with CBSE Class 10 Math online tuitions. It takes all of 5 minutes and less than 3 steps to get started. And second thing, I want you to subscribe to this channel and turn on notifications so that you get notified every time a new video is uploaded. Spread the word about this channel to your friends and classmates.